In today's market, where industries are using various software architectures and applications, it's almost next to impossible to feel that your data is completely secure. So while building these applications using microservices architecture, security issues become more significant as individual services communicate with each other and the client, right? So hello all, this is Sahiti on behalf of Edureka, and I welcome you to this session on microservices security. So in the session, guys, we'll mainly discuss the various ways you can implement to secure your services. So on that note, let's get started with today's session. So the topics for today's session are, as you can see on my screen. We'll start this session by understanding what are microservices, and then I'll tell you the problems faced in microservices. After that, I'll tell you the best practices to secure microservices. Well, guys, the methods that I tell you are not the only methods. Well, I would say in microservice architecture, you have the complete freedom to secure your services based on the application or the architecture that you have, right? So let's get started with today's session. So the first topic for today's session is, what are microservices? Now, what do you think microservices are? Well, microservices are basically small autonomous services or maybe small independent services communicating with each other. So if I have to define microservices for you, then microservices, or most commonly known as microservice architecture, is an architectural style that structures an application as a collection of small autonomous services modeled around a business domain. So you can basically understand microservices as small individual services communicating with each other around a single business logic. So you can have an e-commerce application, right? So for example, let's say Book My Show. Now in Book My Show, what do you see? You see places, you see movies, you see theaters, and then you see the movie timings and maybe which offline shows are working. What I mean by that is that, what are the events happening in your city and so on, right? So what can happen is basically all these features or functionalities can be divided into different services, and then these services can communicate with each other to generate the requested response by the client, right? So that was about microservices, guys. Well, this was a short explanation. If you want an in-depth explanation of microservices, I would say go to my session on microservices, and then you will understand what are microservices in depth. So I hope that you've understood what our microservices are. Now what happens is that, often when companies shift from monolithic architecture to microservices, they see many benefits like scalability, flexibility, short development cycles, and maybe, failure isolation and the flexibility in technology stacks and so on, right? But at the same time, this architecture also introduces complex problems. Well, these problems are basically regarding the security, right? So next in this session on microservices security, let's understand the problems faced in microservices. Well, the problems faced in microservices are, as you can see on my screen. Starting with the first problem, consider a scenario where a user needs to log in to access a resource. Now in microservice architecture, the user login details have to be saved in such a manner that the user is not asked for verification each and every time he or she tries to access that particular resource, right? Now this creates a problem as user details might not be secure and also could be accessed by the third parties. Now obviously, guys, to anybody, user credentials are the most important credentials which have to be secured, right? Now in a scenario where a client is logging into an application to access a resource, the application gets the complete credentials of the user. Now if the credentials are not secured by those services, then that's definitely a problem because anybody can exploit it. So that is one problem that I clearly see. Problem number two is basically, I would say, when a client sends a request, then the client details need to be verified and also the permissions given to the client needs to be checked, right? So when you use microservices, it may happen that, for each and every service, you have to authenticate and authorize the client. So authenticate is basically to check what permissions are given to you, and authorize the client is basically to check who are you, right? So basically the user credentials are checked. Now to do this, developers might use the same code for each and every service, right? So what I mean by that is, when a client is trying to access few data from different services, it may happen that, the client details have to be checked to make sure if the data has to be sent to that person or not, right? Now to check that, maybe a specific code is used in all these services for a specific application. Like service A, B, C, D, E can all use the same code to check the authenticity of the client. But don't you think relying on a specific code reduces the flexibility of microservices? Well, obviously that's a yes, right? So this is one of the major problems also I see in the microservice architecture, that the complete application having various services is based on a single code base. And let's say you build an application now with that particular code in all the services to check the authenticity of the client. But let's say after 10 years, that particular code doesn't work. Now you have to change the code for all these services, and in the same time, you also have to make sure that nobody is exploiting the data from the services, because there will be no security layer then, right? So this is one major problem that I see that that has to be catered. So the next problem that is very prominent in this particular architecture is basically the security of each individual microservice. Now, what I mean by that is basically in this architecture, all the microservices communicate with each other simultaneously in addition to the third-party applications, right? So when a client logs in from a third-party application, you have to make sure that the client does not get the access to the data of microservices in a way that he or she might exploit them, right? So it obviously makes sense because he's logging from a third party application. Now maybe that particular application is not that secure. So maybe instead of the client, the third party application is basically trying to access the data. So we have to make sure that the data is secure, and not every application is given an access to the data in the services, right? So guys, these are few problems that I see very much prominent in microservice architecture. Well, there could be lot other problems based on security of microservices. So these are few problems that I thought would be very prominent, right? Now, obviously, seeing so many problems, we have to figure out a way to secure our services, right? Now, to secure our services, all we can do is we can put up security layers, firewalls, and use some methods to make sure our services are secure, right? So on that note, next in this session, let's see the best practices for microservices security. Well, the best practices for microservices security are a lot. I would not say the ones that I mentioned are the only ones. There are a lot of ways through which you can secure your services. But I would say these are few methods, through which you can start at least securing your services. Or maybe you can figure out a way to at least make sure your data is secured, right? So let's start with the first one, that is defense in depth mechanism. Now, as microservices are known to adopt any mechanism on a granular level, you can apply the defense in depth mechanism to make sure that the services are more secure. Now, what I mean by that is the defense in depth mechanism is basically a technique through which you can apply layers of security countermeasures to protect the sensitive services. So as a developer, you just have to identify the services with the most sensitive information and then apply a number of security layers to protect them. So in this way, you can make sure that any potential attacker cannot crack the security on a single go, and has to go forward and try to crack the other layers in the defense mechanism, right? So basically, if you say, service B is the most sensitive service, which has, a lot of information, which has to be secured, right? So what you can do is you can basically have layers of security, and maybe if some attacker cracks the security of the first layer, he or she has to still go and crack the other layers. But by that time, you'll definitely understand that, there's some problem in security happening, and then you'll again secure your services, right? Also, since in a microservice architecture, you can implement different layers of security on different services, an attacker who is successful in exploiting a particular service might not be able to crack the defense mechanism of the other services. For example, let's say you have service A and service B, and let's say, you have few layers of security on service A and few different layers of security on service B. Now, maybe an attacker who has attacked service A and has cracked the security might not be able to do the same for service B, right? So that was about the defense in depth mechanism, guys. Let's take a look at the second best practice, that is usage of tokens and API gateway. Now, often when you open an application, you see a dialog box saying, accept the license agreement and permission for cookies, right? Now, what does this message signify? Well, once you accept it, your user credentials will be stored and a session will be created. Now, the next time you go on the same page, what will happen is that, the complete page will not be loaded from the server, but will be loaded from the cache memory, right? So I hope that's clear. So for example, let's say, you open bookmyshow.com. So now the first time that you open and then you accept the license agreements and the cookie permissions, what will happen is that your user credentials will be stored and a session will be created. Now, the next time again, maybe sometime later, you open Book My Show again, that particular page will be retrieved from the cache memory rather than the service itself, right? Now, before this concept came into the picture, sessions were stored on a server side centrally. Now, this was one of the major problems, as storing the session centrally was being a barrier to horizontally scaling the application. So to overcome that, what people started doing is basically everybody started using tokens and API gateways to secure the services, right? So what would happen with tokens is that, tokens would be used to record the user credentials. So basically you can understand that, tokens are used to store the user credentials. So these tokens are used to easily identify the user and are stored in the form of cookies. Now, each time a client requests a web page, the request is forwarded to the server, and then the server determines whether the user has access to the requested resource or not, right? Now, the main problem which is prominent in tokens is that the user information is stored, right? So the data of the tokens needs to be encrypted to avoid any other exploitation from third-party resources. And I would say JWT, or most commonly known as JSON Web Format, is an open standard which defines the token format to provide libraries for various languages and also encrypt the user details, right? So guys, just to avoid storing sessions centrally, what people started using is tokens. Now, tokens are used to store the user credentials, and since the user credentials are stored in the tokens, tokens have to be encrypted themselves. So you can go forward and use JWT to encrypt the respective tokens, right? Coming to API gateways, API gateways act as an extra element to secure the services through token authentication. So the API gateway acts as an entry point to all the client requests and efficiently hides the microservices from the client. So the client basically has no direct access to the services, and thus in that way, no client can exploit any of these microservices, right? So what happens is that you have a client and then you have API gateway. Now API gateway will communicate with all the APIs present in the microservices, right? So basically over here, if you visualize, the client has no direct access to the services. Instead, it's just the API gateway, and it's completely the responsibility of the API gateway to forward the request to the respective microservice. So guys, that was about tokens and API gateway. Let's move forward with the third best practice, that is distributed tracing and session management. Now, talking about distributed tracing, all of you might be observing that, while you use microservices, you have to monitor all these services continuously, right? But when you have to monitor a humongous amount of services simultaneously, that definitely becomes a problem, right? For example, if you just have to monitor 5 services, then maybe that's an easy task. But in a scenario, maybe if you have to monitor 50 or 100 tasks simultaneously and 24/7, then that's a problem, right? Now, to avoid such challenges, what you can do is you can use the method of distributed tracing. So distributed tracing is basically a method to pinpoint the failures and identify the reason behind it. Not only this, but you can also identify the place at which the failure is happening. So basically with that, you can easily track down which microservice is facing a security issue. Right? For example, let's say, you have 5 services and then there's some error happening at service B, right? So you can directly go and pinpoint that it is because of service B, there's some failure, and maybe then you can directly go and figure out that, there's some security issue at service B, rather than to check all the services and the complete application, right? So that's what distributed tracing helps you guys. It makes you identify where is the failure happening, why is the failure happening, and then which service is it affecting. Moving on to session management. Session management is an important parameter that you have to consider while securing microservices. Now what happens is that a session is basically created whenever a user comes onto the application. So what you can do is you can handle these sessions in many ways. I could figure out 3 ways. The first way is basically you can store the session data of a single user in a specific server. What I mean by that is the session data of user A is maybe stored on server A. The session data of user B is basically stored on server B. And session data of user C is basically stored on server C, right? So in that way, you can make sure that if there's some exploitation of services, then you can track down which user is doing it directly without having to figure out what is happening and all. You can directly track down that, maybe user A is exploiting or user B or user C, right? But the only problem over here that I see is that, the system is completely based on load balancing between the services, and it meets only horizontal scaling rather than the vertical scaling. So for small applications which, let's say, have 3 to 4 services, maybe this kind of system can be used. But if you want to use this scenario for a large application, then I think that will create a problem, right? Coming to the second way, well, what you can do is the complete session data can be stored on a single instance. Then what can happen is that, the data can be synchronized through the network and the requested responses can be generated. And you can also make sure that, the data doesn't go anywhere, right? So what happens is that, you have a single instance, and then through network, the data is completely circulated between services and the client. Now, the problem, if you think over here, is basically the exhaustion of the network resources, right? For example, let's say you need a data from 10 services, right? And all the data is completely stored on a single instance. Now, all these services have to communicate with that particular instance, get the requested response, and then finally send back to client, right? Now, this is a little bit problematic when you have large services again, but I would say for small services, you can go forward, right? Now, finally, coming to the third method, what you can do is you can make sure that the user data can be obtained from the shared session storage so as to ensure that all the services can read the same session data. So what I mean by that is if you have 5 services and the 5 services need the user data, then the user data is obtained from a shared session storage through which the data can be retrieved, right? But since the data is retrieved from a shared storage, you need to make sure that you have some security mechanism to access the data in a secured way. So basically you have to make sure that you add another security layer, maybe by using the defense in depth mechanism to make sure that the data is encrypted with the help of tokens, or maybe you have a specific firewall that not all of them can access the data and no third party applications can access and only a few admins can access, right? So you can use it the way that you want. So guys, that was about distributed tracing and session management. Let's move forward with the next practice, that is first session and mutual SSL. Now the idea of first session is really simple, guys. What you can do is basically when the users log in for the first time into the application, then they can access all the service in the application, right? So what you can do is whenever the user logins for the first time, you can store his or her details in an encrypted format in a secured way so that they don't have to keep verifying their credentials each and every time they're trying to access different servers. For example, if you have 10 services and maybe the user needs to log into all the 10 services, what you can do is you can have an initial login, and when the user logs in for the first time, maybe he or she gets access to all these services. But the only problem over here is that you have to make sure that the user who is trying to log in is a client himself, and maybe he or she is not an attacker and is not trying to exploit the resources, right? Coming to mutual SSL, applications often face traffic from users, third parties, and also microservices communicating with each other, right? But since these services are accessed by the third parties, there's always a risk of attacks. Now the solution to such scenarios is by using mutual SSL or mutual authentication between microservices. With this, the data transferred between the services will be encrypted, and the only problem with this method is that when the number of microservices increases, then each and every service will have its own TLS certificate. It will be very tough for the developers to update the certificates. Else, if I would say the developers are ready to update the certificate and maybe they're not scaling the number of services, then I think they can go forward with this particular method. As each particular service will have its own TLS certificate, and that particular certificate will define which microservice has what access and which data can be retrieved from each of these services, right? So mutual SSL sounds like a good option, guys. I think you should go forward and all. But the only thing is that when you're scaling your service, you have to make sure that you have to update all these TLS certificates. On that note, let's move forward with the final practice, that is the third-party application access. Now, all of us access applications which are third-party applications, right? So the third-party applications basically use an API token generated by the user in the application to access the required resources. So the third-party applications can access that particular user's data and not the other user credentials. Well, this was with respect to a single user. But what if the applications need to access data from multiple users? How do you think such request is accommodated? Well, I think the solution to this is by using auth. So when you use auth, the application prompts the user to authorize the third-party applications to use the required information and generate a token for it. So generally what happens is that an authorization code is used to request a token to make sure that the user's callback URL is not stolen, right? So in this way, the user or the client communicates with the authorization server while mentioning the access token, and also the authorization server authorizes the client to prevent others from forging the client's identity. So when you use microservices with auth, guys, the services act as a client in the auth architecture to simplify the security issues, right? So I would say, guys, all these methods that that I've explained to you are one of the best practices that I've observed to secure your microservices. But if you ask my personal opinion, I think I would always go for auth with a collaboration of JWT, that is basically generating client tokens, and always follow the defense in depth mechanism to make sure that there are a number of security layers to my services, so that the data stored in my services is completely secure, right? So if you're someone who is aspiring to build an application based on microservices, then remember that the security of the services is one important factor which you need to be cautious about, right? So on that note, guys, I end this session today. I hope you found this session informative. So if you have any further queries related to the session, please comment in the comment section below. Until then, that's all from my side today. Thank you and happy learning.